Hi everyone. Today we are going to discuss about our second chapter, acids, bases and salts. Okay. Okay students. First of all we have to discuss about acids. The taste of acid is sour taste. Acids have sour taste. In our daily life we can see a number of acids in some fruits, in some vegetables. We can see acids. Basically, acids have sour taste. And we have some example. If you enter into the chemistry lab, you can see number of examples for acids. Hydrochloric acid, sulfuric acid, nitric acid. We have a number of examples for acids. And the basic thing, from every acid, when we dissolve the acid into water, we will get hydronium ion. Hydronium ion is H3O+. Okay? So when we dissolve any acids in water, first of all we will get hydronium ion. According to the great scientist Arrhenius, he is telling that whenever we dissolve acid into water, we will get hydronium ion, H3O+ ion. So that is the thing. Acids can give hydronium ion when it is dissolved in water. So when we dissolve acid into water, we will get hydronium ion. In this mechanism, the first step is the releasing of H+ ion from the acid. Hydrochloric acid, sulfuric acid, nitric acid, all acids have H+ ion. So first of all, acid will give H+ ion in the presence of water. Then that H+ ion will combine with the water molecule. Then we will get hydronium ion. So I'm telling to you, acids can give hydronium ion. Next, we can classify the acids into two categories, strong acid and a weak acid. Strong acid will give hydronium ion as soon as possible. But what about weak acid? Weak acid is giving hydronium ion very slowly. We have some weak acids, that acetic acid, carbonic acid. Actually, acetic acid is a component of vinegar. If you dissolve 5 to 7% acetic acid into water, we will get vinegar. Okay? So acetic acid is a weak acid. In the same way, we have carbonic acid. Because we are drinking the soda. Actually, the chemical component of soda consists of water and carbon dioxide. So we have carbonic acid, it's a weak acid. But what about the others? HCl, H2SO4, HNO3, all are strong acid. Okay? Next, I'm telling a very simple test to identify the presence of acid. This is the point. Acids can change blue litmus into red. By using litmus paper, we can examine, we can identify the given solution is acidic or basic. By using a litmus paper, the blue litmus, which is used to find out the presence of acid. So if we use blue litmus, if you are dipping the blue litmus into a solution of acid, that blue litmus paper will be converted into a red litmus paper. So from the color change, we can say we can identify the presence of acid. Okay? So this is a simple test. Litmus paper, by using litmus paper, we can identify the presence of acid in a solution. Then, students, acids have a pH range starting from 0 to 7. First of all, I would like to introduce the pH scale. It has a reading starting from 0 to 14. In that reading, 0 to 7 explains the presence of acid. That is the acidic range, 0 to 7. But in sharp 7, it indicates a neutral solution. But from 7 to 14, that indicates the solution of alkalis or bases. So by using a pH scale, we can distinguish the solutions acidic, basic as well as neutral. So a neutral solution should have a pH range of 7. But for an acidic solution, it has a pH range starting from 0 to 7. And a base should show a pH range starting from 7 to 14. A strong base should have a pH very close to 14, but a strong acid should have a pH very close to 0 or 1. We have hydrochloric acid, we have nitric acid, all should have the pH range in between 0 to 1 or 0 to 2. They are strong acids. They are strong acid. But what about bases like sodium hydroxide and calcium hydroxide? I will teach you the next regarding to the bases. They have a pH range of starting from 7 to 14. I'm telling to you the NaOH, sodium hydroxide. It has a pH range very close to 14. That indicates NaOH is a strong base. We can explain about bases. Yeah, bases have bitter taste. Dear students, acids have sour taste, but bases have bitter taste. And bases have a pH range starting from 7 to 14. I already told you the measurement of pH scale. 7 to 14, which explains the strength of a base. Next, alkalis are bases which are soluble in water. All alkalis are bases, but all bases are not alkalis. So alkalis are those bases which are soluble in water. Okay, alkalis are bases which are soluble in water. We have a number of examples for alkalis: sodium hydroxide, potassium hydroxide, calcium hydroxide. All are strong bases, all are strong alkalis because they are soluble in water. Because they are soluble in water. So dear students, it is very important. Alkalis, they are bases which are soluble in water. Okay. Like that we have magnesium hydroxide, iron hydroxide, copper hydroxide, but all are weak bases. That means if the metal in the base, if it is highly reactive, that base is strong. Why NaOH is a strong base? Because in NaOH we have sodium. Sodium is a highly reactive metal. Like that we have KOH. In KOH we have potassium. Potassium is highly reactive. So highly reactive metal can make number of bases which are strong alkalis. But what about magnesium hydroxide and iron hydroxide and copper hydroxide? They are weak bases. Why they are weak bases? Because they are less reactive metals. So less reactive metal can produce weak bases. See the example: magnesium hydroxide, iron hydroxide, copper hydroxide, in which the metals are magnesium, iron, copper respectively. They are less reactive metal. So less reactive metal can form weak bases. Got it? The last point, bases can change red litmus into blue. I already told you, acid can change blue litmus into red. By using a litmus paper, we can test the presence of bases also. So bases can change red litmus into blue. We have a number of indicators like phenolphthalein and methyl orange. But now I am talking to you about the litmus test. By using a red litmus, you can measure or you can identify the presence of a base. So bases can change red litmus into blue. Okay. As an introduction, I want to discuss with you salt. Actually, salts are formed by the combination of acids as well as bases. It's called a neutralization reaction. In our chemistry textbook, in the second chapter, it is the first chemical property of acid and bases. Whenever acid is combining with the base, we will get salt. See the explanations of salt. salts are formed by the combination of acids as well as bases. So whenever acids are combined with bases, we will get salt. Whenever acids are combined with bases, we will get salt. That reaction is called a neutralization reaction. That reaction is called a neutralization reaction. Why it's a neutralization reaction? Because whenever acid is combining with base, the character of acid as well as the base is lost. Maybe the salt is acidic or basic, it doesn't matter. But the acid and base that we are taking should be lost its character. If you take hydrochloric acid and sodium hydroxide, you will get sodium chloride salt. If you mix sodium hydroxide, a strong base, with a strong acid, hydrochloric acid, definitely you will get sodium chloride. It's a good salt. It's a neutral salt. Why sodium chloride is a neutral salt? A number of times I discussed with you in normal classes that it's a salt formed from strong bases and strong acid. If strong acid and strong bases are combined together, the salt should be neutral. Why the salt is neutral? Because the acid as well as bases both are strong enough to make the salt a neutral one. And we have calcium chloride. It's also a neutral salt because it consists of calcium as well as chlorine. It is formed from the base called calcium hydroxide as well as hydrochloric acid. So, sodium hydroxide, calcium hydroxide, potassium hydroxide, all are strong bases, all are alkalis because they are soluble in water. So, if you mix calcium hydroxide with hydrochloric acid, definitely you will get calcium chloride. That is also a neutral salt. And potassium chloride also, it's a neutral salt because potassium chloride is formed by the combination of potassium hydroxide and hydrochloric acid. The first three salts, NaCl, KCl2, calcium chloride, potassium chloride, all are the results of the reaction between strong acid and strong bases. So I am telling to you, they are neutral salts. But what about sodium carbonate? Can you see the sodium carbonate? It's a basic salt. Why it's a basic salt? Because in sodium carbonate, it is a salt of sodium hydroxide and carbonic acid. Do you know, I already told you carbonic acid is a weak acid. But sodium hydroxide is a strong base. So this salt, Na2CO3, it's a basic salt. Dear students, please listen. This Na2CO3 is a basic salt. But what about FeCl2? FeCl2 is a acidic salt. Why FeCl2 is an acidic salt? Actually, FeCl2 is called ferrous chloride. Why it's a acidic salt? Because this FeCl2 is prepared from weak base FeOH2ase, that is iron hydroxide or ferrous hydroxide as well as hydrochloric acid. So, students, you should see whether the acid is whether the acid is strong or weak. If you have strong acid and a strong base, the salt should be neutral. If you have strong acid and weak base, the salt should be acidic. If you have weak base and a if you have weak acid and a strong base, the salt should be basic. So it is very, very important. Yes, acidic salts are formed by the combination of strong acids and weak bases. Basic salts are formed by the combination of strong bases and weak acid, and neutral salts are formed by the combination of strong acid and a strong base. Here you can see the examples of salts which are showing different character: neutral, acidic as well as basic. And I'm telling to you, the pH range of salt may be varied. A neutral salt should show a pH range of 7, but an acidic salt should show a pH range less than 7. But what about a basic salt? It will show a pH range greater than 7. Okay? Now we are discussing the chemical properties of acids and bases. See the first chemical property, it is the reaction between acids and metals. It is the reaction between acids and a metal. See the examples. Whenever hydrochloric acid is combined with the sodium, you will get sodium chloride and a hydrogen gas. Like that, if you are treating sulfuric acid and sodium, you will get, if you are using sulfuric acid with the calcium, you will get calcium sulfate and hydrogen. So dear students, should listen. If you mix acid with a metal, the result should be the formation of hydrogen gas. Definitely you will get hydrogen gas along with the formation of salt. So acid plus metal gives salt plus hydrogen gas. This is the first chemical property of acid. Now I am discussing with you the chemical properties of acids and bases. So the first one is, whenever acid is combined with metal, you will get salt and hydrogen gas. What about the second one? If you react metal and bases, or if you react bases and metal, the same result is happening. Definitely you will get salt and hydrogen gas. The same result is happening here. You will get salt and hydrogen gas. See the salt, sodium zincate. The salt is sodium zincate. Here, zinc is reacting with the sodium hydroxide. Zinc is a metal and sodium hydroxide is a base. So, listen all of you. When we react sodium hydroxide with the zinc, definitely we will get salt and hydrogen gas. This is the first chemical property of acid as well as base with metal. See the third chemical property, reaction between acids and bases. It is called a neutralization reaction. I already told you what is neutralization. When acid and bases are combined together, you will get salt and water. It is called a neutralization reaction. Here I gave you two examples. When NaOH is reacting with hydrochloric acid, see the result, you will get sodium chloride and water. In the same way, if you are reacting calcium hydroxide and sulfuric acid, the same result is happening. You will get a salt, calcium sulfate and water. So this is the third chemical property, where you can see the acidic nature of acid and the basic nature of bases are losing here. Such a reaction is called a neutralization reaction. Again, I am telling to you, the salt may vary their pH. It depends the strength of acid and bases that you are using. Okay? So the salt may be acidic or basic or neutral. It depends the strength of acid as well as base. Okay? Now we have another chemical property. It's a very simple chemical property of acid. If you have metal carbonate, in our chemistry lab, we have lot of metal carbonates like sodium carbonate as well as potassium carbonate. If you take such a metal carbonate and if you add acids like hydrochloric acid or sulfuric acid, definitely you will get salt, water and carbon dioxide. So you don't forget the general formula or general mechanism. If you react metal carbonate with acid, you will get salt, carbon dioxide and water. This is the two precious example you have. Sodium carbonate as well as potassium carbonate. In these two reactions, We are taking different acid, hydrochloric acid as well as sulfuric acid. What about the salts? If you are taking sodium carbonate and hydrochloric acid, definitely you will get sodium chloride. Why you are getting sodium chloride? Because the metallic part will combine with the chloride ion. Then you will get sodium chloride. After that, you will get water and carbon dioxide. This is happening in the case of potassium carbonate also. When you treat potassium carbonate with sulfuric acid, definitely you will get potassium sulfate, water and carbon dioxide. In the theory classes I told you, you can determine the presence of, or you can identify the presence of carbon dioxide by using calcium hydroxide. Calcium hydroxide is called lime water. So dear students, if you are using lime water, you can identify carbon dioxide because carbon dioxide is a gas. If you pass the carbon dioxide to lime water, which are taking in a test tube, what will happen? That carbon dioxide and lime water will combine together and you will get a milky appearance. A milky appearance will form in that mixture. That means the lime water will change. That means the carbon dioxide will combine with the lime water and you will get an insoluble calcium carbonate that has a milky appearance. So you can test the presence of carbon dioxide by using lime water. Lime water is nothing but calcium hydroxide. So dear students, please listen. If you are using lime water, you can identify the presence of carbon dioxide. If you pass carbon dioxide to lime water, you can see a milky appearance. That is the formation of insoluble calcium carbonate. Because that lime water calcium hydroxide is converting the carbon dioxide into insoluble calcium carbonate. It is called a lime water test. But if you pass excess of carbon dioxide to that particular mixture of milky appearance, a magic will happen. That milky appearance will be lost. You will get a clear solution like a water. So, if you pass excess of carbon dioxide to that calcium carbonate solution, it will become a soluble calcium bicarbonate. Soluble calcium bicarbonate means that milky appearance will be lost. You will get a solution which is almost like water. So I am talking to you. You can identify the presence of carbon dioxide by using lime water. Lime water is a clear solution of calcium hydroxide. But what about slaked lime? It's a suspension of calcium hydroxide. We can see by using our naked eyes the structure or the appearance of calcium hydroxide. That is a suspension. You already learned from the 9th standard about the suspension. So the suspension of calcium hydroxide, it is called slaked lime. So we have lime water. The test is called lime water test. That we are using for test the presence of carbon dioxide. That's a very, very important reaction. Okay? Now the last chemical property we are discussing now, the reaction between metal bicarbonate and acids. The reaction between metal bicarbonate as well as acid. See the two examples. In the first one I am using sodium bicarbonate. Sodium bicarbonate is baking soda. Baking soda is called sodium bicarbonate. So we are using sodium bicarbonate. We are reacting that baking soda or sodium bicarbonate with hydrochloric acid. What will happen? You will get salt, water and carbon dioxide. The same result is happening. Whatever you see after the reaction between metal carbonate and acid, the same reaction is happening here also. Instead of metal carbonate, if you are taking metal bicarbonate, definitely you will get salt, water and carbon dioxide. See, we have sodium chloride, we have water, we have carbon dioxide. We have one more reaction. If you are taking potassium bicarbonate and hydrochloric acid, definitely you will get potassium chloride, water and carbon dioxide. This is also a chemical property of metal bicarbonate. Sorry, it's a chemical property of acid. Because by using acid only we can identify the presence of carbonate as well as metal bicarbonate. Here also we can check, we can identify, we can measure the presence of carbon dioxide by using lime water. Lime water test. Students, don't forget about the lime water test. That is very, very important. Using lime water calcium hydroxide, we can test the presence of carbon dioxide which is formed from the reaction between metal bicarbonate and acid. So from metal bicarbonate and acid, that reaction will give salt, water and carbon dioxide. So I am telling to you, by using lime water we can identify the presence of carbon dioxide. But if you pass excess of carbon dioxide, we will get a soluble calcium bicarbonate. Again I am telling to you, it's a magic. If you pass carbon dioxide first of all into lime water, you will get a milky appearance. But if you pass excess of carbon dioxide, you will get a clear solution. You will get a clear solution. That milky appearance completely lost and you will get a clear solution. That is the best test in front of us to identify the presence of carbon dioxide. So thank you dear students. Have a nice day.